Math relationships. So wavelength and frequency are related by the speed of light. The speed of light is symbolized by the letter c. It's a constant, so the speed of light is always 3.0 times 10 to the 8th meters per second. Max Planck developed the formula that relates energy and frequency. H stands for Planck's constant, so H is always 6.626 times 10 to the negative 34 joules seconds. Joules is the unit for energy. So we have two major formulas in this unit. E equals h nu and C equals lambda nu. Both of those are given to you on your reference table. But there's a third option. Because both of these have frequency in it, we can do a substitution. So if we take the speed of light reaction or formula and we solve for frequency, we would divide both sides by wavelength. So frequency is equal to the speed of light divided by wavelength. Then we can come down here and plug that in for frequency. So E equals hc over, wavelength. So we actually have a third option available to us for our equations. Again, only these two are given to you for the test. You would have to derive the third equation if you wanted to use it. You don't have to though, because you could use both of the other equations. You would just be doing two steps instead of everything in one step. So in our first example, we have 4.0 times 10 to the 15th hertz. Hertz is the unit for frequency. This problem also tells me that that this number is frequency, and the symbol for frequency is the V. I'm looking for what is the energy. So I'm looking for energy, which is a capital E. So then I look at my three equations and I pick the one that has the E and frequency in it together, which would be the Planck's equation. I'm going to put an X in for the E since that's what I'm solving for. H is a constant, and then I can plug in my frequency. And we're going to multiply these numbers together. Now instead of writing hertz, I'm going to use one of the other forms of the unit, which is 1 over S. This will help us determine what the unit is for the answer a little bit easier than using the hertz. Remember, hertz is the same thing as 1 over S or inverse seconds. So then I can take my calculator and plug this in. Make sure when you plug it in that you use the special button for the times 10. We would want two significant figures, so 2.7 times 10 to the negative 18. For the units, we have joules seconds times 1 over second, or joules seconds divided by seconds. So the seconds cancel and I'm left with joules. Energy is measured in joules, so this number would make sense. In number 2, I'm given frequency again, and I know that because of reading the question and it's measured in hertz. But I'm looking for wavelength, which is a symbol of lambda. So I look at my three equations and I pick the one that has both frequency and wavelength in it, which is our speed of light equation. Speed of light is a constant, so I know I can plug in the number 3.0 times 10 to the 8th meters per second. Wavelength is what I'm looking for, so I'm going to use an X, and then I have my frequency. Again, instead of writing hertz, I'm going to do 1 over seconds. So mathematically, to solve for X, I'm going to divide by my frequency. Again, make sure you use the special button in your calculator. We need 4 significant figures. Now for our units, You have a fraction being divided by a fraction. So if you take the reciprocal of the bottom fraction, you would have meters seconds divided by seconds. So the seconds actually cancel out and leave us with just meters. Meters is the unit for length, which makes sense for wavelength. In number 3, we're given energy. I know that this is energy because it has the unit of joules and it says this number of energy. Energy symbol is E. I'm looking for the frequency, and frequency is the nu symbol. So the formula, the equation that has both energy and frequency in it is E equals h nu, or Planck's equation. Plugging my numbers in, E equals Planck's constant times x. So I'm going to divide both sides by Planck's constant to get my x by itself. And I'm going to use my special button. I need 3 significant figures, so I have 1.11 times 10 to the 60, and then I'm going to look at my units. Joules divided by joules seconds, so my joules are going to cancel, but notice that the seconds is on the bottom of this fraction. So I would put 1 over s, or you could do s minus 1, or you could do hertz. All 3 of those are the same exact unit, and they're all the unit for frequency. Number 4 is probably the hardest type of question for 2 reasons. We have energy again because it's in joules and it says the energy is, so that's E. And then we're looking for wavelength, which symbol is lambda. Now this is a hard question because lambda and energy are not in the same equation for the 2 that they give me on the test. So I can either derive the third equation, or I would have to use my Planck's constant equation to solve for frequency and then use my speed of light equation to solve for wavelength. I'm going to use the one-step option. The second reason why this question is a little bit more difficult is because you have to understand that the energy is in kilojoules, but Planck's constant is in joules, so we have to convert. King Henry died unusually drinking chocolate milk. You're going from kilojoules to plain joules, which would be our U. So we're going to move the decimal 1, 2, 3 places to the left. So we have 2050 joules. So we're going to plug in the number. 2050 joules is equal to Planck's constant times our speed of light divided by our wavelength, which is what we're looking for. We would want to multiply both sides by x and then divide by 2050 joules to get x by itself. So plugging this number in all at one time, making sure to use my special button, and I'm going to need 3 significant figures. X ends up being 9.70 times 10 to the negative 29. Now let's look at our units. We have joules divided by joules, so that cancels. Seconds times meters over seconds, so my seconds cancel, leaving me with meters. And again, meters is a unit for length, and we were looking for wavelength, so that would make sense.